Hello, welcome to Pre-Algebra with Miss Betsy. This is the companion video with some examples on it to section 6.1, where we're beginning a review of working with fractions. So I've already given you guys a video that I recorded last year just for the teaching, but I want to go ahead and go through the skill check for you. But the lame joke that I can think of right now says, what is the biggest use of cowhide worldwide? Well, of course it would be to cover cows. So let's see what we can do with these fractions. This should be a total review for you, and you know that I've said in class that I don't want you writing mixed numbers. I want you to keep the fractions as in an improper fraction reduced to lowest terms, because that's the most reasonable way to work with numbers typically in algebraic solutions. But since we're reviewing fractions here and they ask you specifically to convert back and forth from mixed numbers to improper fractions, I want you to go ahead and do this. This is just a review of things that you already know. So we're on page 178. This is Pre-Algebra for Christian Schools, published by Bob Jones University Press, first edition. So we are on page 178. This is skill check number 1. And we have 3/8 is equal to A over 32. And our instructions for these first three problems that I'm going to illustrate to you say this: replace the variable to write an equivalent fraction. And you will remember that from the last video we showed how to convert from one fraction to an equivalent fraction, and we are looking to see what the denominator was multiplied by here so that we would end up with 32. So this is where you need to make sure that you're real solid on your multiplication tables, because that way you can look right here and say, oh, 8 times 4 is 32. So we're going to multiply by 4 in the denominator. 8 times 4 is 32. And you have to multiply by the exact same value in the numerator. 3 times 4 is 12. So we now have an equivalent fraction. We have that 3/8 is the same as 12/32. And the way that we did that, if I could get my hand to write the right numbers, we saw that, how did we get from 8 to 32? We said that 8 times 4 is 32. And let's just say that you didn't have that multiplication fact on at the tip of your tongue, or right here in the front of your memory. How could you have figured it out? Another way to figure it out is to say 32 divided by 8 gives you the 4, because multiplication and division are inverse operations, and they have that relationship between division facts and multiplication facts. So we now have equivalent fractions. So A is equal to 12 in that example right now. So let's look and see what we have for skill check number 2. We have 4/10 is equal to A over 50. So what value are we going to need for A here? Well, we see that the denominator is increased, so we're going to have to say, what can we multiply 10 by to get 50? Well, 10 times 5 is 50, so we're going to multiply both the numerator and the denominator by 5. Multiply numerators together. 4 times 5 is 20, over. Multiply denominators together. 10 times 5 is 50. And what you have, we've written an equivalent fraction for 4/10. So 4/10 is the same as 20 over 50, which means that A has a value of 20. That's all they're wanting you to do with these problems when you're converting into an equivalent fraction, or when you're renaming as an equivalent fraction. You know, that reminds me of I may have said this as a lame joke somewhere. This blonde called up the pizza shop and she was ordering a pizza. And the guy said, how many pieces do you want it cut into? She was ordering a personal pizza. Do you want it cut into 4 pieces, or do you want it cut into 8 pieces? So our blonde said, I'm not very hungry tonight. Just cut it into 4 pieces for me. Well, here's my picture of 2 different pizzas. If we cut it into 4 pieces, and she eats half of it, you know, or she eats the whole thing. She said, I'm not very hungry. I'm going to eat all 4 pieces. Or you have the same one cut into 8 pieces. It doesn't matter if she eats 8 pieces or 4 pieces, because 4/4 of a pizza is the same as 8/8 of a pizza. And let's just say she's going to split it with a friend. She doesn't want to eat 4 pieces, so she is only going to eat 2 pieces of pizza. So here's the 1 piece of pizza, and here's the other piece of pizza. And she didn't want to order to have 8 pieces of pizza because she wasn't hungry enough to eat 4 pieces of pizza. But my really fancy drawing right here says that, you know, that 2/4 is the same as 4/8. And another way to write that, of course, is just cut that pizza in half, and you have 1/2. So we have those 3 different equivalent fractions, and that's all we're doing when we're renaming these. We're just showing a different way to express the same quantity. So let's go ahead and look at example at skill check number 3. And that one is 36/42 is c/7. 36/42 is equal to c/7, and they want us to figure out what c is equal to. So we're going to look at this 42, and we say that 42 has been decreased to 7. Well, how did they do that? Well, you can think 6 times 7 is 42. You can say 47 divided by 6, or 47 divided by 7 is 6, which means this has been divided by 6. So we have 36/42. How did we get from 42 to 7? 42 divided by 6 is equal to 7. So since we divided the numerator by 6, we're also going to divide the denominator by 6. And we see now that 36/42 is the same as 6/7, so we have that c is not equal to c. We have c is equal to 6. So that's what they're talking about here. Now the next part of our skill check says, let's use cross products to decide which pairs of fractions are equivalent. And we're going to write yes or no for each pair of fractions. Either yes, the 2 fractions are equivalent, or no, they are not equivalent. So we have 3/5 and 12/20. This is our first pair of fractions, that's number 4. Our second pair of fractions, we're comparing 2/3 and 5/9. And our problem number 6, or our third pair of fractions that we want to see if they're the same, we have 6/8 and 18/24. And we want to use cross products to determine if these fractions are equivalent. What are cross products? Sort of like when you multiply catty corner, you know, draw an X across your fraction. and we're multiplying. Remember, products are multiplication. So we're saying 3 times 20, is that equal to 5 times 12? 3 times 20 is 60, 5 times 20 is 60. So these values right here, these 60s, are the cross products. Because the cross products are equal, those two fractions are equivalent. 3/5 is equivalent to 12/20. And how did we get from 5 to 20? We said 5 times 4 is 20, which would mean that 3 times 4 would have to be 12, which is exactly what we have. Now we want to see if 2/3 and 5/9 are equivalent. We're going to have 2 times 9, and we're going to see, is that the same as, or is that equal to 3 times 5? Nope. 18 is not equal to 15, so we would say that no, 2/3 and 5/9 are not equivalent fractions. Same thing down here. 6 times 24, is that the same as 8 times 18? Well, 6 times 24 should be 144. You can multiply that out to the side. It's 144. Is that the same as 8 times 18? 8 times 8 is 64. And we see that, yeah, 144 is equal to 144. So these two fractions are equivalent. 6/8 is equivalent to 18/24, but none of these are reduced to lowest terms. When you reduce these to lowest terms, you're going to see that 6/8 is the same as 3/4 when we divide the numerator and denominator by 2, and that 18/24 is also equivalent to or equal to 3/4 when we just divide the numerator and the denominator both by 6. Okay, so that's how you use cross products. When they ask you if two fractions are equivalent, that means do they have the same value? And when they say use cross products, you just multiply your opposing corners. If the products are equal, then that means the fractions are equivalent. Okay? Now this says rename each fraction in lowest terms. And we have 4 of these. 8/10, 9/24, 30/45, 8/10, and I promptly forgot them, 9/24, 30/45, 9/24, and 30/45. I'm not going to do problem number 10. And we're asked now to rename each fraction in lowest terms. And I want to remind you, take you back to page 178, and it says to rename a fraction in lowest terms, you divide the numerator and denominator by their greatest common factor. And then they have another way that you can reduce this, and I'll do that example, that method for our last number. First it says, figure out what the greatest common factor is for 9, for number 8, and number 9. What do we have for our greatest common factor here? Well, 2 is our GCF, and I'm not going to go back through how you find the GCF. That would be section 5.6, 5.7. You just finished learning about how to find the greatest common factor, but the greatest common factor of 8 and 10 is 2. We divide both the numerator and the denominator by 2. And we've reduced that fraction to lowest terms. The greatest common denominator of 9 and 24 is 3. So we're going to divide the numerator and the denominator by 3. 9 divided by 3 is 3. 24 divided by 3 is 8. So 9/24 reduces to lowest terms as 3/8. And then finally, this other method that they had here, I think this is actually problem number 7 and problem number 8. Problem number 9, another way of reducing a fraction to lowest terms rather than dividing by the greatest common factor is first rewrite this as a product of primes, which means you would need to prime factor, or you would need to know at least the prime factorization of these numbers. So if we prime factor 30, using a factor tree, there are any number of different ways that you could come up with the prime factorization of 30, but you would have 30 being equal to 2 times 3 is 6 times 5 is 30. So we are going to rewrite our numerator and denominator as in prime factored form. So rather than 30, we have 2 times 3 times 5 divided by 45, but we need to prime factor 45. 45, 9 times 5 is 45. 3 times 3 is 9. And we now have our prime factored form because our bottom numbers, the whole way around here, these are all prime numbers. So we have 3 times 3 times 5. We've rewritten our our unreduced fraction here, 30 over 45, so that both the numerator and the denominator are in prime factored form. Now we can cancel common factors. 3 divides into 3 as 1. 5 divides into 5 one time. What do we have left? We have 2 times 1 times 1, which is 2. And we have 1 times 3 times 1, which is 2/3. So here, for problem number 9, we have taken 30 over 45 and reduced that to lowest terms by first prime factoring. For problems 7 and 8, we simply divided the numerator and the denominator by their greatest common factor. So whichever methodology you need to use, or you prefer to use, will be just fine. We're looking for always a fraction reduced to lowest terms. So if you have any difficulties, send me a text.